the volume of 1,2,3-propane triol, which is called glycerol, which has a density of 1.261 grams per milliliter and a molar mass of 92.095 grams per mole, containing 1 mole of oxygen atoms. Okay, so we're going to start with 1 mole, or number of moles of oxygen atoms. We're going to convert that to the moles of compound. Okay, and the moles of compound we're going to convert to the mass of the compound because we have the molar mass there. And then the mass of the compound will convert to volume, which is what it's asking us, using the density. So moles of oxygen to moles of propane triol to mass of propane triol to volume of propane triol. Notice it's always good to make a roadmap where you're going. If you just start off writing things down, chances are you may go astray before you get to the end. Maybe not after you've done this a while. But I want you to be able to do it with accuracy and with confidence, because you're going to need that in the test. If you do 20 questions in 75 minutes, you're not going to have a whole lot of extra time to go back and redo something. You want to do it right the first time. So make the map. It's really worthwhile. So now we have 1 mole of oxygen atoms. And we want to convert that to moles of compound. Now, how are we going to know that? What do we need? We need a formula, don't we? We got to have the formula of this, because over here we're going to need to have moles of oxygen under moles of compound, whatever it is. So, how do we solve that? Well, let's look at the name. We'll get the name like we did last time. We'll take the name, we'll draw the structural formula, and then we'll get the molecular formula. And that's what we use to get this conversion factor. So 1,2,3 propane triol. Propane says 3 carbons. Okay. 1,2,3 says there's an alcohol group on each one of the carbons. And what are in the rest of the places? Hydrogens. Good, good. Hydrogens fill up the rest. So there's 3 carbons, C3. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, right? Yes? Or below? No, does not matter. This is just a strictly 2-dimensional thing. C3H, what was it? 8O3. C3H8O3. So 1 mole of C3H8O3 has how many moles of oxygen? 3 moles of oxygen. So that's how we have to get the formula. We have to know how to take the name, draw the structural formula. From that we get the molecular formula. Everybody comfortable with that? Okay, now we have to get the mass of this. So this says 92.095 grams of C3H8O3 per mole. So that is a mole to mass conversion step, right? Okay. So now it's in grams. All we have to do now is to convert it to volume. And we'll assume that volume in milliliters will be all right since it doesn't say anything. So we have 1 milliliter over 1.261 grams. That's what the density is. This is the inverse of the density. And I know I have to use the inverse because I have to get rid of the grams. They got to cancel out and get it to milliliters. And when I do that, if I did my math correctly, I got 24.3. milliliters of C3H8O3. So we can do, this is really very flexible. We can do a lot with it. It's a powerful approach to things, and if you learn to use it, it'll be a very flexible tool for your